today we are going to solve one problem that is related with the derivation tree. First, we are going to listen that what is the context-free grammar, and after that, how to define the derivation tree from the context-free grammar. So, first of all, what is context-free grammar? Basically, if we say context-free grammar, that is CFG, consisting of a finite set of grammar rules, is a quadpole, that is N, T, P and S, where N is a set of non-terminal symbols and T is a set of terminals, where N, T, that is null. So there is no combination common between N and T, and P is the set of rules. So P is a N yog T, that is left hand side of the production rules. P does not have any right contents or a left content. So S is the start symbol. So anywhere in the quad pole, S always the start symbol. So let's take one example, like here is the example, the grammar, that is a set of set A, set ABC, P and A, where P is the A, where A belongs to small and A is again belongs to BC. So A is equal to ABC also. And another example is the grammar, that is set of capital S, AB, AB and P and S. So here P that contains S, and S means A, capital S, A. So S also belongs to B, capital S, B, and S belongs to infinite. That is way we can derive the content-free grammar definition. So now we are going to derive the derivation tree. So what is the derivation tree? So derivation tree is also called as a parse tree, which is an order rooted tree that graphically represents the semantic information, a string derived from a content-free grammar. So first of all, let's start with some terminologies that comes with the derivation tree. So what is root workers? First of all, that is like a start symbol. So it always start with the start symbol, which means it's root vertex. That is also necessary in this. Second is a vertex. Vertex is labeled by a non-terminal symbol, which is not mean to that derivation tree. Next is a leaves, labeled by a terminal symbol or epsilon, like we saw in the above example, example number 2, where S belongs with epsilon. It means it comes with everything. Now we can represent a derivation in the language generated by a content-free grammar by an ordered rooted tree called a derivation or a parse tree. So the root of the trees represent the start symbol, and the internal vertices represent the non-terminal symbols that arise in the derivation, and the leaves represent the terminal symbol that arise. So after when we discuss about the how the derivation tree looks like, you can identify the different types of terminologies, like what is root vertex, how it looks, what is vertex and what is leaves. Next, if the production A, that is W, where W is a word arise in the derivation, the vertex that represents A has a children vertex that represent each symbol in W in order from left to right. Here, let's represent one sentence. The hungry rabbits eats quickly. So that is a full sentence. If we derive the sentence, it divided in the noun phrase and the verb phrase. If we again derive the noun phrase, it comes with the article, adjective and the noun. So here article is the, adjective is hungry and noun is repeat. If we derive the verb phrase, it's again derived in the verb and adverb. Here verb is eats, adverb is quickly. A derivation tree for the derivation of the hungry rabbit can eat quickly given the grammar described earlier. Let's take one example of that. Here, let's determine whether the word CBAB belongs to the language generated by the grammar G. Here, it's VTSP, where V belongs to ABC, capital ABC and S. Let's take T as small abc, and S is a starting symbol. And the productions are S, that is AB, A, that is CA, B, that is BA, B is again that is CB, and so we can derive is like B to C, C to CB and C to B. Now, how can we find out that this is the proper, and how we define the another value of CB and A? So one way to approach this problem is to begin with S. S is a starting point and attempt to derive the CBAB using the series of production. Because there are only one production with the S on its left hand side, we must start with the S takes as a AB. Next, we use the only production that is A on the left hand side, namely A, that is capital CA. To obtain S, that is AB, and AB comes to CAB, because CBAB begins with the symbol CB, we use the production C, that is CB. This given us as, that is AB, as A's value is CA, so we put a replace A with the CA and it comes with the CAB. Now again B's value is known as a C's value known as a CB, so it comes with the CBAB command again. We finished by using the production B, capital B, that is equal to small b. To obtain S, we put AB is equal to CAB, again C is equal to CB, so CBAB, again capital B is small b, so it's everything small CBAB. The approach that we have used is called the top-down parsing because it begins with the starting symbol and proceeds by successively applying productions. There is another approach for this problem called the bottom-up parsing. In this approach, we work backend because CBAB is the string to be derived. We can use the production C, that is small cb, CAB, that is CBAB. Then we can use the production A, that is CA. So AB is equal to CAB, is equal to CBAB. You know now that how we have derived this. So using the production B, that is small b, gives capital AB, that is capital A, and small b, and CB is equal to CBAB. Finally, using S, that is AB, shows that a complete derivation for CBAB is as, that is AB, equal to small ab equal to CAB, that is CB.